Hello and welcome. So let's start with few more questions of linear algebra. So today what we are going to do, we will be solving 2019 paper from statistics, and we have already solved 2020, 21, 22, 23 paper from statistics that you can go through. Also, we have solved mathematics pyq, last 5 year pyq. So those are all in the same playlist, and we are solving according to the syllabus of data science, artificial intelligence, and subject is linear algebra. Okay, so let's start with 2019 paper from statistics, and let's directly jump onto the questions. So we have our first question, that is question number 5. The dimension of vector space of 7 by 7 real symmetric matrices with trace 0 and the sum of off diagonal elements is 0. so so we have to find the dimension of vector space of 7 by 7 real symmetric matrices. So the point is that we have to find the dimension of this matrices in this space, right? So how we can do that? So if we know that how many elements do we need to specify that particular matrix, then we can comment about the dimension, right? So if we need maybe if we need uh, that 49 elements to specify 7 by 7 matrix, that is its dimension will be 49. But we have given conditions, a few conditions, that matrix should be symmetric, that the trace should be 0, and the sum of the off diagonal should add up to 0. So these, with these conditions, then what will be the dimension of the matrix, right? Let's form a 7 by 7 matrix, maybe. So 1, 2, 3, 4, 5, 6, 7, and what we will do, according to the given condition, uh, we will see that how many elements do we need to specify the matrix, right? So let's take the elements like that, maybe. So and then we will according to the condition, we will uh, look at what elements do we need, or what elements can be derived from the given condition. So let me also first of all, let me also mark the main diagonal element and the off diagonal element. So this is the main diagonal element, right? And this will be our off diagonal element, right? So 1, 2, 3, 4, 5, 6, 7, right? And we have given that matrix is symmetric. So if if we know that let's say here, if it is A, then here it will be A, right? Because we have given that it is symmetric. So across the diagonal, these two elements would be same, right? Similarly, we can say if it is here B, then it is B, C, C, D, D, E, E, F, and here it will be F, right? So 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 with this condition, with the symmetric condition, what we can say, that that if we know these elements, then we also know these elements, right? And if we know these elements, then we have info about these elements, right? If we have info about these elements, then we also know these elements. If we have info about these elements, then we also know these. similarly, if we know this, and then we will know this, right? So we the main point is that we need this upper part, right? And if we know these upper part, then we will have the info about the lower part. So this upper part will help the matrix to form, right? If we know these elements, then we also know the lower part. So lower part is known when upper part is known, right? And let's look at this off diagonal element. So you see that off diagonal element, here these that if here we have 1, then here we will have, if it is 1 here, then we will have 1 here. If it is 2 here, then here we will have 2 here, according to symmetricity, right? But this element, what we can pick this. So we can pick this according to this condition: sum of the diagonal elements should be 0. So if we know these 3, then we have info about these 3. Also we have info about this the center one, because with the given condition, this center one will be the minus times 2 times sum of the 2 plus 1 plus f, right? So so to specify the off diagonal element, we need only these 3, and that is all, right? So we do not, right? And with this main diagonal, the trace should be add up to 0. So you can take any number, like maybe 4, 5, 6 here, and 7 here, and 8 here, and it should be add up to 0, right? Then this element should be minus times of sum of the other diagonal element, right? So if you know the other diagonal element, then you know this one, right? So we do not need this to have, right? If we have these info, then we know this one also. So it will not add up to the dimension anything, right? So these two will not add up to the dimension, these two. And what will be getting add up to that contribute to dimension, let me count, that will be our answer, right? Okay, what happened? So we will have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 and 21 22 23 24 25 and 26. So we need 26 element to specify the complete 7 by 7 matrix with this space and with this given condition. So the correct answer for this is 26. So the correct answer for 5 is 26. Okay, now let's jump to next question. This question number 6 is based on this Jordan block. So this is not in our data science AI syllabus. Also it is a complex matrix, so I hope so we will not get any question from this. And this is minimal polynomial. These are not in DS AI syllabus, and this is not a matrix question. This is probability question. Okay, let me just jump directly onto the last question, that is question number 55. And what we have given, that I be a 4 by 4 identity matrix, and we have given this, and this is and where T is the transpose, then the determinant of I plus B V transpose is equals to. So to find the determinant, first of all we need to find this thing, right? So let's find this v transpose, right? So we have given is 1 2 3 4, and v transpose we have given 1 2 3 4. We can do the multiplication, we will get the 4 by 4 matrix, right? So the multiplication would result 1 2 3 4 and 2 4 6 8 and 3 6 9 12, and here we will have 4 8 12 16, right? And if we want to have I plus v transpose, then we will simply add 1 to the diagonal elements, right? So it will be 2 2 3 4, and here we will have 2 5 6 8, here we will have 3 6 10 12, and here we will have 4 8 12 17, right? Now we will have to find the determinant of this matrix, right? So you can easily expand and you can find the dimension, but how I can we can also adopt another approach, that is we can do the elimination, and once we have the upper triangular matrix, then we can multiply all the diagonal element, that will be the determinant of the determinant of this matrix. So let's proceed with the elimination. So we can keep our first, so this is pivot, so we can keep first row as it is, and in second row what we can do, we can subtract the first row, so it will be 0. So the main aim to pick this pivot and make these guy 0, right? So it will be 5 minus 2, that is 3, 6 minus 3, that is 3, 8 minus 4, that is 4. And if you want to make this 0, then we will have the multiplier that will be 3 by 2, so it will be 0, and here we will have 6 minus 2 into 3 by 2, so it will be 3, and here we will have 10 minus 3 into 3 by 2, so here we will have 11 by 2, right? 20 minus 9, 11 by 2, correct. Here we will have 12 minus 4 into 3 by 2, so here we will have 12 minus 6, that is 6. And next we want to make this 0, so our multiplier would be 4 divided by 2, that is 2. So we will multiply 2 with the first row and then subtract it from the last row, right? So it will be 0, and 8 minus 4 4, and 12 minus 6 6, and 17 minus 8 9, right? Now next what we will do, next we will pick this as a pivot, and we will make these guys 0, right? So let's do the elimination further, and we will have the first row as it is, and second row have no effect, and a third row here it will be 0, here we will have 0, and 11 by 2 minus 3, so 11 by 2 minus 3, right? So it will be 5 by 2, so here we will have 5 by 2, and 6 minus 4, that is 2, right? And now we will make this guy 0, so our multiplier will be 4 by 3, so here we are going to have 0 anyhow, and here we will have 6 minus 3 into 4 by 3, so here we will have 2, and now 9 minus 4 into 4 by 3, so here we will have 27 minus 16 divided by 3, so it will be 11 by 3, right? I hope I'm not making any mistake. So yes, now what we can do, we can pick this one as a pivot, right? So our multiplier would be 5 2 divided by 5 by 2, so 4 divided by 5. So we will have to make this guy 0, so this will be 0, and here it will be 11 by 3 minus 2 into 4 divided by 5, so we will have 15, and 55 minus 24, right? So we will have 31 divided by 50. So what, after doing the elimination, it will be 31 divided by 15. So it will be 31 divided by 15. Now we have our this is the upper triangular, right? You see that this one is an upper triangular, and what we can do, we can simply, to find the determinant of this matrix, we can simply multiply the diagonal element. So it is 2 into 3 into 5 by 2 into 31 divided by 15. So here we will have 3 5 5 5 2 2, so 31. So determinant of this matrix will be 31. So 31 is the correct answer. Okay, that was two questions from 2019 paper. Next, what I am going to do, since we have solved last five PYQ from statistics, so now I will be solving EC paper, EC math, and in math we will solve particularly linear algebra. Then we will go to CSC, and in math we will solve linear algebra, and then we will end up with the IT paper with math, linear algebra. Same way we will be planning for the probability also, right? Okay, that is all from this lecture. We'll meet in next lecture.